you guys notice about our sunspot activity over the last 400 years?
It went up.
Getting very active in the 2000s.
Sure, yeah, we get spikes of activity here. In fact, these cycles are happening every 11 years. We have a maximum and a
Aliens.
trough every 11 years. What else do you notice?
Aliens.
Projection.
The joke.
Your Honor.
Wasn't there a CME in 2002?
They happen all the time.
No, not coronal mass ejections, though.
Sure, they do. They happen.
Yeah, but they would wipe out all of it.
It depends on where. So imagine you have the sun, the ball.
Time, but there was
It
one
was.
that affected sun.
Yeah.
Oh, sure, yeah, for sure.
About costs us everything.
If it happened all the time, we wouldn't have internet. I mean, it happens all the time, but you know.
We wouldn't have.
I
Don't
was talking about
worry
specifically
about the
when-
internet. You wouldn't have
You
a
gotta
car.
remember too that they're going to have different strengths.
Yeah.
So some are going to be weaker than others, and like if you have the sun,
Faraday
your
cage.
Earth, a coronal mass ejection could go that way and it wouldn't affect us at all.
Or if it's big enough, it could kill us all.
Because look at this. What do you notice from about 1645 to 1715? What's happening with the sunspots there? We don't have that many happening. So
Because we started making technology?
no,
Oh, okay.
we can't affect the sun like that. But during this period, if the sun isn't as active, what would you expect to happen on Earth as a result of that?
Nothing.
The sun wasn't shooting as much energy our way.
Less life.
That's why. What happened to the temperature?
It was lower.
Lower. Well, it just so happens that in the UK, around that same time, the exact same time actually, during what we call the Little Ice Age, the River Thames froze over. The last time the River Thames froze over completely was 200 years ago. But during this time, it was frozen so thick that they had frozen river festivals and elephants were walking across it. It was frozen for the entire winter and only started to thaw in April, and people only left when the ice actually started to break up, even though there was a bunch of water on the surface. Think about it. A river today that's never frozen over was frozen so thick that thousands of people went out on it. They were doing all sorts of stuff. They had horses and buggies, you had elephants pooping all over the place, walking around. They had shows, fire eaters, all sorts of stuff happening because the sun wasn't as active. Yeah.
Wait, so it's supposed to be like that without climate change? It's supposed to freeze over?
What do you mean supposed to?
Like, if we hadn't affected it like we have, would it still be freezing over?
I don't know. That's a good question. We need to learn more before we can figure that. So this guys is an example of a change that happened relatively quickly, but it took a while to change, the Little Ice Age, okay? The next one, this is your in an afternoon event, okay? And this is one that when I was in your guys' position, when I was in high school, no one knew any of this stuff. The research began in 2007, and we're still learning stuff constantly today. So the stuff that I'm about to tell you is stuff that not a lot of people are even aware of happening, okay? So, once again, astronomy. If we look at our solar system, if we zoom way out of this picture, eventually we get to an area that's like a giant cloud of comets, trillions with the T comets. And they're in pretty stable orbit. They're in kind of like a sphere, but occasionally certain things happen and it can like disrupt their orbit. And those comets will fall into the inner solar system towards the sun. And as they get closer to that star, they break apart. That's what the tail is. And it leaves behind a trail of debris. And as we orbit the sun, the Earth interacts with those paths and makes a, what did you say? A meteor shower. That's how we can predict them, because we know where those paths of debris are. And we know where they're coming from, a certain part of the sky, too. And one of my favorites is the Taurids. The Taurid meteor stream happens around Halloween and about 6 months later. And in 1993, during the Taurids, there was a comet called Shoemaker-Levy 9 that was a part of that debris. And it approached Jupiter.
Wait, what?
This is Jupiter. Jupiter is the biggest and baddest planet of them all in our solar system. It sucks in debris from all around it, and a lot of people think it protects Earth from impacts and things that would be really bad for our life on this planet. And in 1993, Shoemaker-Levy 9 is approaching, and the tidal forces of Jupiter ripped it into pieces, into a string, like a string of pearls. Except each pearl is a deadly ball of ice approaching the planet at over 100,000 miles an hour. And when it hit Jupiter, we could see it from Earth, the explosion, with our naked eye, and the explosion itself was bigger than our planet.
Wait, what? How can you...
at nighttime, if you
Oh.
look up, you can see Jupiter, and we could see it get brighter with these explosions happening. And to put this in perspective, one of these fragments, the first large one right here, when it exploded, released more energy than 100 times the world's nuclear arsenal combined at the height of the Cold War. So you're talking Hiroshima, that's nothing compared to what we're talking about here.
That was an
This
atomic bomb.
dwarfs anything we are capable of doing right now.
Did it like knock the planet out of orbit or something?
No, I don't think so.
No.
Jupiter is big and bad. It would take way more than this to affect it that way. It's horrible.
I'd take like,
What would
yeah,
happen
it'd
if
take
that
some
happened
massive.
on Earth? Would it just
Well,
be completely
we'd
all
die.
like
See, that's a
obliterated?
great question, and it's a great segue, because looking at the moon, we can tell that impacts happen, right? A lot of these larger ones are ones that we think happened as the moon was forming. But some of the smaller ones, like this one, Tycho crater, that one happened, we think, about 65 million years ago. What else happened on Earth roughly 65 million years ago?
The
meteor.
Yeah.
dinosaurs.
Dinosaurs died, right? So, how did the dinosaurs die? We think an impact event.
Is there like so is that what most people believe, like most scientists believe?
Yeah.
is a meteor?
And let's see why we think
We
that.
know.
So some of the times when things in our solar system, and when we see like meteors and stuff coming in, they burn up in the atmosphere, they blow up, they don't actually get to the ground. And it has to be pretty big to actually get to the ground. But a lot of comets, especially, they're not that dense, they can't make that trip through our thick atmosphere. And so they will blow up in the air. We call them bolides. And one of those happened, once again, part of the Taurid meteor stream in 1908 in Tunguska, Russia, which is like a really remote part of the area. Not a lot of people were there to see it, but there was one guy, a farmer, that lived pretty close
It
by.
blinded him.
He was telling a story about how he was sitting in a chair in front of his house and he was getting drunk. And he felt a really, really hot sensation on the back of his head, and then he woke up a few meters away. Because this impact blew up right by his house. And when I say right by, I'm talking like miles and miles away.
And the
When
shockwave
this
got
thing
him.
hit, it leveled almost every single tree in an area 5 times bigger than Chattanooga and
It's
South
outward.
So
500
just think
miles.
about what that would do if it blew up over a city today.
I know we learned about space.
We are learning about space, and that's why I love climate change.
So
Love it.
many people have it.
So this happened in 1908, but something much bigger happened 65 million years ago, and we know that it was an impact because we find evidence for it in the rocks.
Literally
okay?
everywhere.
This layer right here, we call the KT boundary, or the Cretaceous Tertiary boundary, and it's special because below this layer, we can find all the skeletons of all the dinosaurs that used to live. But above that layer, we find none of them. They all died during that event. I mean, some of them, like the smaller ones that survived, and now they're birds, but most of the big ones, they all got wiped out. And when we started to really pick apart this layer and learn about what was in it, we found some interesting things. Some of the stuff we found were tiny little hexagonal nanodiamonds that can only form, that we're aware of, in impact events in like really high pressure, high heat, high energy environments. What's up?
Sorry if I'm asking too many
No,
questions,
go
but
for it.
isn't there like a huge crater they found where they're pretty sure is where it hit?
Mhm.
I'll show you where that is.
I know what you
Yeah,
can.
no, you're good. I love it. If you guys have questions, please ask. That's why I'm here.
Have you seen the recent discovery that they made of a fully, like, completely preserved feathered dinosaur tail in amber?
Yes,
So
it's
cool.
pretty awesome. I mean, before that, I mean, look at this picture. No feathers.
Yeah.
And that's how it was like my entire life. And now we're starting to realize that these things are more beautiful and different than we ever imagined. So it's really special. But in this layer, we found